Most PGT done today is done on embryos that have reached the blastocyst stage. Embryos can become blastocysts after growing for 5 days, 6 days, or sometimes 7 days in the laboratory. And the reason that we do genetic testing on blastocysts and that we don't do it any earlier is because once an embryo has developed into a blastocyst, we can start to see what parts of the embryo are going to develop into what. And so there's an outer layer of the embryo that we call the trophectoderm. This is the area that would eventually develop into the placenta, the organ that connects the baby to the person carrying the pregnancy. And then there's a cluster of cells in the middle of the embryo called the inner cell mass. Those are the cells that would eventually develop into the baby itself if a pregnancy was formed. And so being able to see these two distinct areas really helps us make sure that the genetic testing can be done in a way that is safe. It is not safe for us to do genetic testing directly on the inner cell mass, the area that's going to develop into the baby. And so what they do in order to do genetic testing on the embryo is they take what we call a trophectoderm biopsy. So they remove about 5 to 10 cells from the area of the embryo that would become the placenta. All of those cells are opened up so that we can get the genetic material that's inside of them. And then the genetic material is combined into one sample.